Alright, in this video we're going to look at section 2.5, day 1, multiple angle and power reducing formulas. So the first set of formulas we're going to be looking at are double angle formulas. Just like your sum and difference, you do not have to have these memorized. I'll give these to you on any sort of assessment that we're going to have. These are going to be used to help us get rid of sines and cosines and tangents if we need to in order to solve. All of these things can be derived from our sum and difference. So if you had sine of u plus u, you could use your sum and difference formula to get 2 sine u cosine u. Cosine 2u, you notice, has squares, and that's because the sum and difference formula for cosine of u plus u would be cosine u minus sine u, and that's where the sine and cosine squares are coming from. And then these two down here are just turning the sine squared into 1 minus cosine squared, and like vice versa here, turning the cosine squared into 1 minus sine squared. So jumping in, kind of looking at how we can use the double angle formulas, solve 2 cosine x plus sine of 2x. So this is one of those ones where we have a problem. We can't really solve this, we can't factor, we can't do anything because we have cosine and sine. So if we take advantage of the double angle formula for sine, we can rewrite this thing as 2 cosine of x plus 2 sine x cosine x. And then equals 0. And that's because of our double angle formula that we just looked at on the previous slide. Now what we can do is we have a cosine in common. We also have a 2 in common. So let's go ahead and factor out a 2 cosine of x. And that's going to leave us with 1 plus sine of x equals 0. And now all we have to do, just like we did in the last couple of sections, is set each of these things equal to 0 and solve. So 2 cosine of x equals 0 is really just cosine of x equals 0. 1 plus sine of x equals 0 gives us sine of x equals 1/2. So if we look at the unit circle, cosine of x equals 0 when x equals pi over 2 and 3 pi over 2. And sine of x equals -1 when x is equal to 3 pi over 2. So we have 3 pi over 2 listed twice, so really we can get rid of that because it's already listed here. So another way we can use this is use the fact that cosine of theta equals 5 over 13, and theta is in between 3 pi over 4 and 2 pi. I'm sorry, and that's a typo. That should be 3 pi over 2. 3 pi over 2. To find sine of 2 theta, cosine theta, 2 theta, and tangent of 2 theta. Well, all this little thing right here means is that we are in quadrant 4. So that allows us to know that sine, or cosine rather, is positive, but we also know that sine and tangent are going to be negative. So that's what this little thing here is telling us, is when we get our answer for sine and tangent, we're going to be negative. So what we want to do is start with this cosine of theta equals 5 over 13. I don't know what angle on the unit circle has 5 over 13, so we're going to draw a triangle. So we'll call this theta. This is going to be 5. That's going to be 13. If we use our Pythagorean theorem, we're going to end up with a 12 right here for this. So we know that cosine of theta is equal to 5 over 13. Sine of theta would be equal to -12 over 13, right? Because remember, sine and tangent are going to be negative. And we could figure out the tangent of theta, but that's not going to really help us too much because we're trying to find sine of 2 theta, cosine 2 theta, tangent 2 theta. And the reason we found these is because we can use our multiple angle formulas to help us here. So if we're trying to find the sine of 2 theta, we know from our formula that that's equal to 2 sine of theta, cosine of theta. Well, we now know what sine and cosine of theta are, so that's 2 times -12 over 13 times 5 over 13. And that's going to give us negative 120 over 169. So sine of 2 theta is going to be negative 120 over 169. Now we can look at cosine of 2 theta. Now we have three different options. All of them are going to be acceptable to figure out what cosine of 2 theta is. I would like to use one of the ones that deals with just sine or cosine. That way we don't have to have multiple things going on. And since cosine's positive, let's use that one. But again, any of the three formulas would work. So we know that that's going to be 2 cosine squared of theta minus 1 for our cosine of 2 theta. So we're looking at 2 times the cosine we know is 5 over 13 squared minus 1. If you work that out, you're going to get negative 119 over 169. So before you start thinking, well, I thought we're in quadrant 4, so cosine had to be positive. Theta is in quadrant 4. We're finding the cosine of 2 theta. So we're not actually necessarily staying in quadrant 4. Now, there is double angle formulas, or I should say there is a double angle formula for tangent, but we can take advantage of quotient identities. Tangent of 2 theta is going to be equal to sine of 2 theta over cosine of 2 theta. So since we already know what sine and cosine of 2 theta are, we don't have to worry about trying to figure out using the formula. So if we multiply by our reciprocal here, we're going to end up at 120 over 119. Now, if you wanted to go through and use your double angle formula on that one, you could, but this is going to be a lot quicker since we already know sine and cosine. So the next things we're going to talk about are power reducing formulas. So if we don't want a square, we can use these power reducing formulas. We could also, if we wanted to, use them backward if we have the right stuff. So we could make cosine of 2u, and this is basically using our double angle formula, but if you multiply by 2 and subtract 1, cosine 2u is going to be 2 cosine squared of u minus 1. So these kind of derive from those that we had in our double angle formulas. So looking at an example of what we might be asked to do is write the sine to the 4th of x as a sum of first powers of the cosines of multiple angles. So there's two things we need to worry about here. First powers, so no squares, thirds, or fourths, and we're only allowed to use cosines. So what we can do first is we can think of sine to the 4th of x being sine squared of x squared. And what that's going to allow us to do is use our power reducing formula to turn sine squared of x into 1 minus cosine of 2u over 2, and then square that. So if we square that, we are going to get 1 minus 2 cosine 2u plus cosine squared of 2u all over 4. Or, sorry, these should all be x's, but we'll fix that in the next one. Let's go ahead and just factor out a 1/4 to kind of get the fraction out of the way. So we can make this 1 minus 2 cosine of 2x plus cosine squared of 2x. So we've met one of our conditions, right? We have cosines. Problem is we don't have first powers. We have a square still. So we're actually going to end up having to use our power reducing formula again. So the 1 minus 2 cosine of 2x is going to stay, but we're going to have to change that cosine squared of 2x into 1 plus cosine of 4x over 2. And the 4x comes from the fact that we already had a 2x inside, and our power reducing formula tells us to double what's on the inside. So if we double 2x, we get 4x. So we can go ahead and distribute this 1/4 back through because we already have a fraction here. So let's go ahead and distribute that back through. We're going to get 1/4 minus 1, we'll say cosine of 2x over 2, right? 2 and the 4 are going to cancel. Plus 1 plus cosine of 4x over 8. And technically we can be finished there because we have the sum of first powers of cosines. Now you could try to get common denominators and all of that stuff, but for now we'll just kind of keep it where it is because we've met the conditions of the problem. Alright, last thing we're going to talk about is the half angle formulas. So we've seen double angle formulas where we have 2u, now we have u divided by 2. They're all going to be, or the sine and cosine are plus or minus, and then it's the square root of 1 minus cosine u over 2 and 1 plus cosine u over 2. It's going to be dependent on where u over 2 lies. So this plus or minus isn't always going to be there. It just depends on what quadrant you're in. If u over 2 is in quadrant 1, they're both going to be positive. Quadrant 2, cosine will be negative, sine will be positive, and so on. So let's look at a quick example, and then we'll call it quits on this video. We want to solve 2 minus sine squared of x equals 2 cosine squared of x over 2. So what we want to do first is get rid of the x over 2, the cosine of x over 2. So we can think of this as 2 minus sine squared of x equals 2 times the quantity cosine of x over 2 squared. I'm going to kind of rewrite this square so we can look at just cosine of x over 2 for now. So 2 minus sine squared of x equals 2 times, plus or minus, because we don't know what quadrant we're in necessarily, the square root of 1 plus cosine of x over 2. And then we have that squared out there still. Now it's going to turn out that it doesn't matter what quadrant we're in. This plus or minus is going to be irrelevant because we're squaring. Whenever we square something, it's going to turn positive. The square of a square root is going to cancel out. So we're going to be looking at 2 minus sine squared of x equals 2 times 1 plus cosine of x over 2. Your 2's can cancel, so 2 minus sine squared of x equals 1 plus cosine of x. And now it's just solving like we've been doing recently, so I want everything in terms of sines or cosines. I can turn this sine into a cosine, so we're going to say 2 minus 1 minus cosine squared of x equals 1 plus cosine of x. Distribute your negative. 2 minus 1 plus cosine squared of x equals 1 plus cosine of x. 2 minus 1 is 1. Subtract this 1 to the other side. That goes away. Subtract this cosine. So we're going to get cosine squared of x minus cosine of x equals 0. Factor a cosine. And set each piece equals 0. And we're going to get, by our unit circle, cosine of 0 is, cosine of x is 0 when x equals pi over 2 and 3 pi over 2. And then cosine equals 1 at x equals 0. So that'll do it for this video. We will see you in the next one.